All right. Hello, everyone. My name is Jess Nessery. I'm an associate professor of politics and international affairs here at Wake Forest University. Welcome to the International Methods Colloquium. The IMC is a periodic online interactive seminar discussion on the application of quantitative statistical methodology to the social sciences, sponsored by Wake Forest University and previously sponsored by Rice University and the National Science Foundation. The IMC is affiliated with the Society for Political Methodology, who hopes that you will support quantitative research in political science by joining. The membership fee is just $10 a year for graduate students. I will post a link to join the society in the Zoom webinar chat window after this introduction. This week's speaker is Walter Mebane, professor of political science and statistics at the University of Michigan, who's waving there. His talk, as you can see, is entitled Agent-Based Models, Using Agent-Based Models to Simulate Electoral Equilibria, Including Frauds. The talk will last 30 to 40 minutes, after which we will take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window, and you can ask a question at any time, but we hold the questions till the end, as is common for political science talks, but you can ask them anytime you like. A link to Walter's paper and slideshow will be available in the Zoom webinar chat window so that you can refer to it throughout the presentation. And I'll post that right after we're done here. And now I'd like to welcome Walter Mebane to the IMC. Welcome.
Thanks very much. So you see my title slide here includes Fabrizio Vassalai. He's a grad student here, PhD student, who was a co-author of the linked paper, which we presented at Political Methodology Society last summer. So the slides here include some of the slides I showed there. Any of the audience was at that meeting and in that panel, but it's updating a few things and I'm adding several things. And so some of the work, especially toward the end, I'll attribute to Fabrizio. Specifically, I hoped and he had hoped to join me here on this presentation today, but some things came up and so he can't be here today. So the idea of this agent-based model, election fraud kind of thing, this is part of my project, which I call election forensics. And the first, I call it bullet point here. I guess it's an arrowhead, but I'll use bullet point. Is a definition of election forensics as I see it. It's the use of statistical methods to determine whether the results of an election accurately reflect the intentions of the electors. That's a bit of a mouthful, but the mouthful reflects the complications that arise in what I call election forensics. The origin of the whole attempt to use statistics came in the middle 2000s when there was a lot of worry in the United States, especially about the use of all electronic voting machines with no paper records, which are unauditable. And so one has no idea really where the electronic vote counts come from. And so the options are, the best one, of course, is don't do that, use paper. But the second one, if you're forced to use electronics, can you do nothing? And so my election forensics project, among other ways, started there. You might say it started earlier with the 2000 election, but that's a sad story I won't get into right now. So the key challenge, which leads to the complexity in the definition of election forensics, is that it's not merely a matter of finding anomalies. And so you might imagine the methodology could be based on taking numerical or maybe even other kinds of evidence and just seeing if things look weird. And so you define patterns that you think are normal and then say that's weird and you're done. The problem is that, at least I think, elections are characterized by strategic behavior by the electors, the voters, and even by the non-voters. And so this means, as anyone who pays attention to politics realizes, strange things can happen. Many is the candidate who has declared, I was doing so well in the polls, a week or two before the election, and how come I got like 1 or 2% of the vote? And we think, well, you were abandoned because your supporters didn't think you were going to win. And so they voted for their second choice or third choice instead, who was doing better. And so that's a situation where the electors, as this 1.5 bullet point here says, or 2.5, I suppose, electors act not only based on what they want, defined by their own tastes, to use an economics kind of term, but on their expectations about what others will do. And this is called politics, or normal politics, if I'm being a little longer. And the idea in political science, of course, has been realized by game theorists, especially, but others invoking equilibrium notions like Nash equilibrium to have the solutions that occur if everyone acts in some sense optimally in this strategic way. But you can have strategic behavior where people are doing it badly as well. And this behavior means you introduce a couple of problems with the anomaly thing. One is that you get results where the votes are more or less varied than they would be, is one way of putting it, or people's votes are dependent on one another and not independent across electors. And this leads to other side effects, such as there's clustering or multimodality or grouping or clumping. All those words kind of go together to get the vagueness of which I understand this at the moment. But you get data displays that can look anomalous. And so you can fool these statistical methods I've observed, and we'll show you a couple of examples in this part of this talk. And so the problem is to discriminate normal politics and the sometimes weirdness it induces compared to the results produced by what we call frauds. And I won't get into a long discourse about frauds because that varies a lot depending upon the electoral system in the sense of things that are legal in one place or illegal in another. So you can't use legality or anything like that really to get at this notion of frauds. Well, the idea we have, just to short circuit that whole problem, but this is where the frontier of the research is now, because I and others have invented a lot of good statistical methods that can detect many kinds of anomalies. And I even have a method I'll show you in a minute that purports to estimate the number of frauds by polling station or precinct or even voting machine. But the idea is to use agent-based models, or I think Fabricio these days calls them multi-agent systems. These things are the same. And what we're going to do here is simulate elections. And so we worked a while, and this was sort of the force of our PolMeth paper from last summer. We've worked hard to see whether we can impose equilibrium behavior on these agents who are aware of what other agents who are the electors in the kind of simulations we've done so far. And so we can get elections that are at equilibria. We've gotten a lot of pushback about, doing this strong equilibrium analysis, and I won't really talk about that very much. Maybe people in the Q&A will raise that issue. I can talk about that issue now at that point. But ideally, going forward, we'd also like to add frauds to these simulations. And I'll say a bit about the question of whether the frauds are just randomly jittering the data or are reflected by strategic malefactors. I'll say that we haven't done any of that yet, but I'll say a bit about how that might go. And so we take the simulated data where we know exactly what happened because we simulated the data. So we'll know whether it's various strategies and where the strategies were, what they were, and we'll know where the frauds were. And then we can see whether the election statistical methods, the forensics methods, can they discriminate? And even more, and I won't get into this part of the plan so much in this talk, but we can use the agent-based models to improve the way that the statistical tools can be used in kind of a discrimination systems. So a lot of people have, or a few people, I suppose, have done really good work using classifiers, to use a broad term, to try to classify election frauds versus not frauds. So we can combine the kind of features extracted by these various statistical methods with various kinds of machine learning devices to hopefully produce a much better system. And also answer the question of, is it possible to discriminate strategic behavior from fraudulent behavior? So a tiny hint of that will come in toward the end. I should say this whole talk and this project is more prospective than retrospective, in the sense that we've certainly developed the agent-based models, at least simple versions of them, and I have a bunch of statistical tools, but putting the whole package together and seeing whether we can do this discrimination task is the work I plan to do over the next year or so, actually next years. But this is the core of the election forensics project. It's why it's hard, really, maybe impossible, but I haven't given up on it yet. I want to start with just some motivation for the kind of problems that can come up. And this motivation for the next several slides has to do with starting with the real world and just pointing out things that the latest, greatest invention from me and my team, the eForensics R package, that gives signs of possibly, in fact, very often reacting to normal politics, which is partly strategic behavior or maybe largely. And it also is sensitive to frauds, but the issue is, well, you'll see what the issues are. So eForensics, as it says at the bottom of the screen, is a Bayesian finite mixture model. We had support from the National Science Foundation. Grant just ended last summer. And so we successfully achieved the main goals of that grant. The first reference here is to the GitHub site where the code is. And then this is our POLMET paper from a couple of years ago that's not exactly the eForensics model, but a lot of it's here. And this third citation is some class notes I made for my undergrads when I inflicted the eForensics model on them in a course last fall. So if you're interested in the details of this, you can read more about it there. All I'll say here about it is that what it does is it estimates the number of frauds and breaks frauds into two different types for the purposes here. One is it thinks there's fraud that can occur because votes are manufactured from abstentions. So you have people who didn't really vote, but they're counted as having voted. And you might call this ballot box stuffing or other kinds of things like that. So that's this column called turnout here, but the main term is at the footnote. This is the manufactured votes. The other thing the model does is it counts as frauds votes that are stolen for a leader candidate, who's the candidate who the model says can benefit from frauds. And so these are called votes here, but these are the stolen. And the total of those two is the total number of stolen votes, or total number of fraudulent votes, according to this model. So I applied this in this particular slide to several elections from the state of Georgia in 2018, to an election from Mexico in 2006, and Bolivian presidential election in 2019. You'll see more applications in the next couple of slides. And long story short, in Georgia, this shows lots of frauds in the governor's election, which has been challenged a lot, and I won't go on about that. But here's the margin between the winner, the leader in the terminology here, and the second place candidate. And even the number of manufactured votes, according to the eForensics model, is greater than the margin between the leader and the second place candidate. So you'd say frauds decided this election of this type, and add the stolen votes and look at the total number of fraudulent votes, and it's overwhelmingly fraudulent according to that model. The other statewide elections that are shown here do not have that feature, and that for none of them is the number of fraudulent votes bigger than the margin. But on the other hand, it's not zero either. So a naive story might be, well, there's a lot of fraud in Georgian elections, and hold that thought, I suppose. Mexico 2006 was famous because millions of people were in the street protesting. And yes, this model says that the margin was smaller than the number of fraudulent votes. Bolivia led to the president having to leave his office and is exiled. And there was a coup, if you listen to that, to him argue. And in this case, his margin is clearly bigger than the number of frauds, but the issue is that he had to win by more than 10%. And so it turns out, and I have a note about this on my webpage somewhere, that the difference here is not bigger than 10%. And so he still would have won according to this model. But if you shift some of these votes to the second place party, then you can get to a situation where he wouldn't have gotten 10%. And there's an issue of whether those votes really would have been shifted, and that gets complicated. But all these results sort of look plausible. But the problem is, for thinking about the model, is that the story about Georgia and the governor's race is a story told about voter suppression, people not being able to vote. And the eForensics model is about votes being added, not lost. And so it seems like this large fraudulent count is coming from the lost votes being represented by the model as having been added to the leader. And maybe it's right, but it's not literally what the model is designed to do. I have 400 elections from around the world. Most of these are precinct polling station level data. Some are voting box or voting machine data. There's one county level data set, which you'll see prominently mentioned in a second. And so a lot of countries have a lot of elections have a lot of frauds. And so you might think, oh my goodness, well, the model might be showing a lot of spurious stuff, but there's a lot of fraud, and maybe you think a minimal bit of fraud is just noise from the model. And so maybe expect it to sort of be what we statisticians call elliptical, and it's not really. So, the x-axis here is the proportion of votes won by the leader, subtracting out the votes that were manufactured or stolen. And so I'm honoring that by calling it the true vote. We call it the fraud-free votes. And then it's not really related to the number proportion manufactured or stolen, weekly. But the main feature is this extra mode here to spot, which is like the non-elliptical part of the distribution. And this mode here. And so what countries are in here? That's these spots here. And so, maybe there's something more going on there than just a kind of buzz down at the bottom. So the first point is that out of these 401 elections that are all in that point cloud, only 21 of them are exactly zero. 4 elections from German Länder elections, the one county level data set, which I have in because I'm in Michigan and I use this for teaching purposes, Michigan 2010 governor, no frauds. And then the scattering of elections, mostly from the United States, though there's a surprising Puerto Rican result, and Sarasota 2006 might be surprising to some people. So only 21 out of 401. And so what about the others? And so taking the elections that are in this mode right here, right? And so those points turn out to be these elections. And so the first bullet point kind of has a bunch of non-US elections that people who know these elections will probably mostly nod. And no one is surprised to see fraud in Armenia or in Russia or South Africa, I suppose. I'm not sure about Sierra Leone being so well known for that. But these state elections, there's a lot of legislative elections for the most part. And you might get nervous because it's like 5 to 8% manufactured fraud. So it's not negligible, it's like substantial. And the long story short here is that I diagnose these as situations where, again, votes are being lost because of gerrymandering, especially in the United States. So people who are in the wrong party in a gerrymandered district just tend not to vote. And so those lost votes are causing this model to signal frauds for the winner. But, if you don't consider gerrymandering to be fraud, which is debatable, I suppose, but it's not fraud in the sense of this model, the model is getting fooled by this strategic, if that's what it is, reaction to this situation. So that leads to the kind of thing we had in the POMEF paper, and I'll just briefly touch on some of that. The POMEF paper has been updated in various ways in our minds. We haven't actually written it down yet, so some of these slides reflect some of the errors we know about in that paper, but I'll mention them, but not really show the corrections here. And so the strategic abstention goes back to Palfrey and Rosenthal, especially, are the authors of the kind of model we're using here, and authors called Demeklis and Dillon updated it in 2010, and we're following their treatment. And the wasted vote logic comes from work, especially by Gary Cox. And so the POMEF paper describes those two models separately. Here I'm describing the combination of the two models, which hasn't been done before, as far as I could tell, using, I'll call it paper and pencil methods. And so this is slightly innovative, but it's not really the main focus of our work. This is just a kind of proof of concept that we could do these kind of things that go slightly, and we want to go eventually greatly beyond what people have done using formal game theory stuff. And so the key notion here is these pivotal probabilities. The Poisson distribution that shows up here reflects to our using Poisson games to satisfy the calculations, and I'll say a bit more about that in a few minutes. And we have more than two parties, which is a generalization beyond the Palfrey-Rosenthal setting for strategic abstention. And we have the possibility that people don't vote, which is the generalization beyond the kind of consideration that Gary Cox was considering in his, one of my favorite papers is the Gary Cox paper from the, 90s by now, or 2000s. So these are the pivotal probabilities of breaking or making a tie between the top two parties. And the idea in this theory is that people evaluate their expected utility if they vote and if they don't vote. And of course, they'll do the thing that gives them the highest expected utility. So you can do this calculation to elaborate under the 4 possible conditions that they're voting, making or breaking ties or abstaining. And then you can compare the probabilities, the payoffs, because you're multiplying it by their utility, so to speak, from each of the candidates in the case of voting versus not voting. And so you get this expression, and I guess McKelvey and Oderschrick are shown here because they did a lot of this even before Palfrey and Rosenthal. And so, you end up with the famous PB minus C formulation, where the probabilities come from these pivotal probabilities, and the benefits are the difference of the utilities. So this is the basic motivation that shows up for the instrumental voting we're having our agents do. So we have an electorate of these agents in these agent-based models, and they do these kind of calculations and decide whether to turn out and whether to vote based on these considerations. And you'll see a bit more about that in a second. So to evaluate these pivotal probabilities, as I said, we use the Poisson games kind of formulation. And we also use the Skellum probabilities because they were computationally more efficient than some alternatives. And I have more to say about that in about 10 slides or so. But this is some of the way you write down formally the Skellum probabilities. And this expression for the pivotal probability is actually not correct. I'll show you the correct version of it in a few slides. But this is not actually the way it's computed either. And Fabrizio knows a whole lot more about the detailed computational features of how this is done. And so he's presenting papers at conferences coming up with the next few months, and you can see his work for some comments about that. So to the issue of what the agents do, we're imagining that the agents, and this is setting up to follow the treatment of Demeklis and Dillon, and also Palfrey and Rosenthal. We imagine that agents have mixed strategies, and so the probability of voting is not necessarily 0 or 1, but could be a probability intermediate. And so we show that the mixed strategy of elector I is in the closed interval between 0 and 1. And so we have a mixed strategy for turning out, but there's a conditional pure strategy for voting given that they vote. And if they do vote, then this is going to be the rule they're going to use to choose which party to vote for. And so you could count the number of votes in equilibrium is when I care about it, but you can count it at any particular stage as these things update. So you can count the number of votes by aggregating across electors to take the probability that they turn out multiplied by the indicator for which party they voted for. And so from Demeklis and Dillon, we see this learning formulation for how to start basically arbitrary configurations of these mixed strategies across electors, and then evolve them, so to speak. It's not really evolution. It's each elector isn't born or die. They're all the same throughout the whole agent-based simulation, the way we do it now. But they change their views, and you can do a differential equation kind of change. And you see the basic thing is that they're comparing PB minus C based on the party they're going to vote for, or all the parties. And if they evaluate that they're better off voting than their costs, then they should increase their probability of voting. And if it's negative, then they should decrease. And so this function K can take general forms. Demeklis and Dillon say, they don't use in their paper, but they say, and we use in our simulations, because doing agent-based models with differential equation updates proved to be a little challenging to think about. So we use difference equation updates. And so here you see the difference equation formulation where we have this adaptive term K here for the scale that they're going to make the changes, but the sign of the change depends on their choice compared to their costs. And so agents will change in this way, and eventually, in every case we've seen, eventually they will stabilize and you get to an equilibrium. I care only about equilibrium configurations, and my Fabricio, I think, well, he has maybe different views about that for his other interests. And Samuel Baltz, the other co-author of the Polmeth paper, I'm not sure if he is interested in the path to equilibria as well as equilibria itself, but we will show some things where we can see the paths. But for the project I'm talking about of applying this to generate electorates, my view now is that I just want electorates where everything's in this dynamic kind of equilibrium here. So it's not Nash, but presumably it has similar properties in the same way that like Corno. Well, anyway, I won't get into that. So we do some replications in the Polmeth paper. And so Demeklis and Dillon have a figure that actually comes from Palfrey and Rosenthal, more or less. And so setting random utilities for the start and making sure that the balance is at half the electorate support one candidate versus the other. So this doesn't have wasted vote stuff. It's just about strategic abstention. And so with the expected electorate size of 400, this is roughly speaking the figure we're trying to replicate. The lines here show equilibrium positions, and there's also a full turnout equilibrium. The actual figure they show in their paper differs in various ways from this, but I won't get into that in the interest of time. We managed to more or less replicate this pattern. And so we have several different simulations for different configurations of starting values. And we get the downward part and we get a little bit of the full turnout part, but we never get the upper high turnout equilibrium consideration. And we've talked a lot about why that is. And it may be because of the iterative. Anyway, it's different, but similar. It could be a feature of some of the errors that are in the formulation, but I don't really think so exactly. But I haven't, maybe Fabricio has fully simulated, replicated this setting with the model. But anyway, it's pretty good, and we'll leave it at that. If it doesn't exactly replicate the theory here, I think it's still good enough for me to carry forward to use for my simulated electorates kind of idea. So we also simulated separately the wasted vote kind of dynamic from Gary Cox, again, kind of turning off the strategic abstention part. And with diverse utilities, we end up with mostly what Cox called Duvergerian equilibria, exactly two candidates getting a positive number of votes or a non-negligible number of votes with a single seat. And so that's what we found, and whether that's a universal pattern or not, we don't know exactly that yet. The combined model is really what we are wanting to show, that we can go beyond what people have done previously. And so if we add both strategic abstention and wasted vote logic together with a variety of distributions for the costs, sort of U-shaped and bow-shaped and uniform, and utilities with diverse kind of distributions, we find equilibrium configurations that are, I can show the graph of them. Each of the dots in here shows the average strategy value. Recall the strategies are numbers between 0 and 1. And so a lot of strategies on average across the whole electorate of 1,000 electors are intermediate, only in several cases. In the case of the really U-shaped costs, this is a beta 10-10 distribution. And so in that case, we end up with a bunch of things with zero turnout, and we're a little bit concerned that zero turnout occurs, but I won't spend time talking about that right now. But it's important to realize that this wide diversity in the average Q does not match the diversity among electors in this equilibrium configuration. And so the actual number of equilibrium configuration places where an individual elector has an equilibrium value of Q that's not either 0 or 1, well, it turned out to be relatively few electors across most of the configurations. You see, the modal number is not 0, actually, it's 1 in this most interesting case where all costs are positive. So the diversity comes, and this is emphasizing that point again, this particular slide, the number who are between 0.25 and 0.75, which is, not nearly 0 or 1, is pretty, well, it's not negligible, but it's 1 or 2 electors. So that's a thing that we're wondering about. And there's more work on that in the paper that I won't spend time talking about right now. this particular election system, maybe this will generalize to other kinds of electorates and strategies, but this is something we'll have to find out. Also, we wanted to see whether this particular system with these electors reproduces the general wisdom. I'll cite here Meyerson and Weber about this, that you have multiple equilibria in general situations. And so we try identical utilities with just different starting values, essentially, and we get multiple equilibria. So here are 4 of them. And you see here the one elector that's got an intermediate kind of utility, strategic mixed strategy of turning out. And all the other electors are either 1 or 0, and they kind of overlap. So, but anyway, there are 4 different, these are the vote counts for the 5 parties in this case. And you see there are many, probably other equilibria besides this, but here are 4 of them. And I've said before, we don't really care, and I don't really care about things out of equilibrium, but just for curiosity, here's the phase plot showing the movement of the total number of votes for the 2 parties that were the winners, starting from their initial position, which is designated with a 0 on it. You can see their votes kind of went up and then back down again, and then did the little spiral and then stopped here. And there are a lot of different paths here, and this one has a lot of wiggles. So you can get a lot of movement out of equilibrium, but I don't really have a way of thinking about that. I'm not personally all that interested in this. Fabrizio and Samuel especially have reported that it's important to note that our use of agent-based models here is kind of different from the usage a lot of complex systems people make of this, because they're interested in like emergent properties and other kinds of things. We're not doing that, or I'm not interested in that. I'll just say I'm not interested in that. Really, I'm really interested in this equilibrium notion and using this to support work on election forensics. We also have more of these dynamic paths. This is kind of showing what we can do with the data. And this makes the point that while the aggregate numbers, which these are like the averages for the overall electors, these have settled down pretty quickly, but individual electors, the dotted lines are showing the paths for individual electors. They can be pretty bouncy for a long time until you get to equilibrium. And so it's not really the case that you can have movement. We didn't see any movement among electors once you got to equilibrium, and Samuel Baltz has some results on that. But there's a lot of movement under the hood along the way, I'll put it that way. Future extensions that we'll have for this, and coming back to the examples I showed that the e-forensics model found a lot of frauds in especially these legislative elections and in Georgia, where the story in Georgia was voter suppression, even though the governor's race uniquely was affected there and not the others, which makes that not exactly what's probably going on there. And the legislative elections, through my very short gerrymandering story leading to declining turnout as a kind of lost votes. Maybe it's not voter suppression, but it's certainly lost votes. This strategic duty notion or bandwagon kind of strategies, I think, is going to be something that's very important for trying to get at what goes on in a lot of elections that probably triggers several kinds of these statistical methods. The other thing that I haven't implemented at all, neither of these have we implemented. The other thing that I've seen in some kinds of these data are that, especially this could be the story for South Africa, for example, coalitions where the ANC, African National Congress Party, is itself kind of a giant coalition. And so that can lead to voters acting in ways that are more similar than independent, perhaps trigger spurious kinds of signals of fraud for some cases. There's several countries that are like that. So we're looking forward to building these complex kind of strategies into these agent-based models, and these are just 2 of them. The other kind of extension, which we haven't really done much at all, is to add the frauds. And so the issue is, well, you can add frauds in a couple of different ways. And so you might have frauds that are misinformation. A key thing in our situation is that the voters or the electors know at each iteration what the configuration of strategies is at that moment, or at least the summary statistics of the net strategies. And so we can imagine having frauds where there's misinformation about the true vote intentions versus actually changing the vote intentions. And so the misinformation will be the reality hasn't changed, but people are misinformed about it. and the real one would be it's really different. And of course, they could either know about it being different or not. And so those are a couple of alternatives we'll have to, I think, are important to play with that have realistic mappings to the world. And the other issue is, are the frauds just kind of imposed by random selection or just imposed by the designer of the simulation? Or do we imagine that the frauds are created by equilibrium actors in the game who are equilibrium actors? So Fabrizio especially has played with strategic parties, with strategic electors. And so that seems to be feasible, though it has some complications. And so we're imagining, or at least I've imagined, and he kind of said this isn't a crazy idea, we could have strategic malefactors. A lot of books that people have written with fraud being dealt with using game theory models have had strategic fraud being created by authoritarian leaders and vote buyers and agents and things like that. So that those could be models that we could figure out ways to build into our agent-based models and see how that goes. So these are interesting prospects that I hope to pursue pretty soon. I want to quickly show the kind of corrections, and this comes from a paper by Fabrizio that's in the references to this slides you can see. And so his main issue is twofold. First is to make sure that we're not missing much by using this Poisson games assumption instead of the usual fixed electorate assumption, which you see in most paper and pencil treatments of the formal models. And so this is just some quick notation, which I don't have time to really go through. But I'm just showing here he's compared the usual fixed electorate multinomial definition for the pivotal probabilities. And here I'm showing the probability of creating a tie, beta making a tie, breaking a tie looks similar. And then you have this, then you have the skellum, which we used here, which depends on special assumptions to be valid, I'll put it that way. And then he also worked up, we're using Poisson games, so why not use a Poisson formulation for the pivotal probabilities? And the development he has here, which is beyond what we've seen done in most of the literature, is to not restrict multi-way ties. Most of the papers that we saw assume that 3 and higher way ties are not possible. And so Fabrizio has brought that back in. It turns out it's important in our setting not to rule those out because we get some spurious behavior in the agent-based models when we rule out the ties that go away when we allow higher order ties. And so see Fabrizio's work for the further details about that and our work as we go forward. But the questions are, A, comparing the multinomial, which is the black line, to the Poisson, which is the gray line, to the skellum. This really illustrates that the multinomial really gets computationally demanding. And so we are right to think that while it may be feasible to do, and this is electorates of only 100, so even 1,000 or more, this is clearly a curve that's going to Jupiter. So we wouldn't want to do that. And the difference between Poisson and skellum is also a bit notable. So it may be even a slight benefit from doing the skellum, but maybe it's not as dramatic as the difference between that and multinomial. They all kind of end up in the same place. So this graph shows comparing whether they agree on the vote counts and on the ordering of the candidates and the identity of the winner. And the point is they all agree pretty highly, especially once you get to an electorate that's not small. So we're not really missing much, at least with the particular kind of models we're using here. Whether this generalizes to other kind of electoral systems remains to be seen. So the last thing I want to end up with really quickly is that we took we showed this in the Polmeth paper. We took the agent electors that we have here and generated a kind of stapled together a bunch of these simulations and called it a simulated electorate. And there's no fraud in this simulation. And so we're applying various election forensics tests, digit and unimodality tests from the election forensics toolkit, which is originated about 2015, Arturus Rostenau's Spikes model, the likelihood finite mixture model, which I loved and then made obsolete by inventing eForensics. So I'm kind of sad about that, but oh well. And so eForensics, so we applied all of these to these simulated data that have no frauds. And you can see mostly the toolkit digit test, the ever interesting second digit test does show some frauds for the second candidate. And I won't say much about this because it's controversial whether this test is a good measure of frauds, but there's a spurious signal here. More disturbingly, perhaps, the likelihood finite mixture model estimates a significant, this is a likelihood ratio statistic with 4 degrees of freedom, chi-squared, so it's really significant frauds, and there are no frauds. Happily, eForensics does not find frauds, estimates 0 frauds for these simulated data, and the spikes model also does not show any frauds. So, this is not really designed to bang on this, it's just see if it works or not, works in the sense of the models are fooled. Just to summarize then, so we have, I think, demonstrated that we can use ABMs and with the Poisson game information structure, and we, in the Palmeth paper, wanted to replicate basic equilibrium results from well-known models, and we kind of replicate them, I'll put it that way, and then generalize, and we were able to do that pretty well. We wanted to see, and we only did this a tiny bit, to see how sensitive election forensics methods are to strategic behavior. To say we have an example that a couple of examples are somewhat sensitive, but we need to pursue this much more generally with a wider range of strategic configurations. And the idea here is that with the ABMs, we can get quantitatively specific information that at least looks sort of analytical, has an analogy to formal theory, even if it may not be exactly Nash equilibrium. It's very similar in its motivation. And we want to use this to use more tools from machine learning. I'll just have an idea that involves generative adversarial networks and this stuff. And so then we can develop a discrimination, see if it's possible to discriminate frauds from strategic behavior, and if so, set up a machine that can do that. And without doing that, we have the problem that strategic behavior, I'm firmly convinced, can create what I call a buzz that on the one hand can mask, or the other hand can look like signals of frauds, and therefore you can get fooled. And so I'm done. So Justin, we can go to Q&A.
All right. Thanks for that presentation, Walter. At this point, Walter Mebane is available to take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window. And while we're waiting for questions to come in, I have a few questions of my own. So just for clarification purposes, why is it that, just as a matter of sort of maybe not specific mathematical mechanics, but sort of the mechanics of what shows up in the vote counts, why would, let's say, strategic abstention show up as the same as fraud? Why does the model think that's fraud?
Well, that's something I don't really know exactly, but let me give you my idea, which is that the model assumes that you have kind of an over-dispersed binomial distribution of the votes between a leader and opposition. All the other parties in the eForensics model in particular are treated as opposition. And so you're getting a distribution that if everybody voted, so to speak, would produce one kind of pattern of distribution of, P versus 1 minus P for the two parties. But in the case of frauds, in a non-random way, probably, some of the votes for one of the parties disappear. And so instead of the actual P you get, or P sub I, where I is the index for the precinct, you get some of them artificially low. And that distortion in the pattern, because it's not uniformly removing votes across all of the precincts, it's haphazardly or even in a clustered way, because maybe the suppressed voters, to use that phrase, might live in the same places and therefore be adjacent. Plus, they all, even if they're not physically adjacent, they all have the same propensities, and so the P they would have cast looks the same, and so it's kind of decreased in the same way. And so now you have a model which has a distortion. There are, in a sense, too many of the leader's votes and too few of the candidate that was or party that was subject to these losses. And so the model picks up this distortion, and the best thing it can do is to say, well, the model cannot represent lost votes. It simply adds votes. It cannot subtract. And so in order to get the distribution that's closest to the data in the model terms, it adds votes to the other party, and therefore produces different Q and Q1 minus Q, say, that match the pattern. But instead of doing that by subtracting votes from the party that got slammed, it added votes to the leading party, and that shows up as frauds. And so I think that kind of generic, the model cannot subtract, therefore it adds, which is kind of an identification thing. And we thought about adding the capacities to subtract too, but then it's unclear how you probably have two different models you can fit. You can always subtract to get to a pattern from the loser, or you can add to the winner, and then trying to pick which of those you should do becomes the challenge. But I think in this case, since we take away the option to subtract from the loser, everything's represented by adding to the winner, and so that particular model is fooled in that way.
I'm surprised that the strategic behavior you focused on was all about the voters, because it seems like parties also and candidates take strategic action. So, for example, if they know an election is going to be close, they focus their get out the vote efforts. They, do canvassing and literally carry old people to the polls or whatever. But in elections they think are not going to be very close, they don't put in money, they don't do canvassing, and so you can get the sort of strategic investment of resources and that comes out in turnout and also comes out in the margin of the election. And those are different than the voters' choices, right? Because the voters are making their own choices based on their own costs, and then the parties are choosing to raise or lower those costs because they want to influence the election. So how does this, is this a concern for the route that the research is going on now, or is this party strategy going to be captured in the voter strategy?
I think it's a question in literature whether that kind of closeness, the close election has higher turnout, is kind of the pattern people have looked at. And the argument is, well, it's not really strategic. How much is it strategic behavior versus a reaction to hoopla, I think is the term that shows up in a lot of those papers. And the hoopla is a symptom of the strategic behavior by parties and candidates you were talking about. If they think it's close, then they'll put more effort to get out the vote kind of stuff and so forth. Part of me doesn't care about that distinction, because if it turns out that hoopla indirectly makes voters respond to others' expected behavior, so maybe that no individual voter knows that other voters are really going to vote and therefore make it close, but they see the signal from the hoopla, and so with this mediating kind of variable, to sneak that term in, which I probably shouldn't have done, then they effectively react to the fact that the election was going to be close, but they wouldn't have done so without the intermediate action by these elites who are doing the work to inform them. So that turns out, to my mind, to be pretty much the same story with the same consequences. Ideally, you could maybe model the behavior of these parties or campaigns to say they will invest more resources when it's close, and we can certainly simulate that in the agent-based model, and maybe make it equilibrium activity to campaign, in the spirit of, is that fraud? Well, it's not fraud. It's just giving more resources when it's close. But if you imagine it's asymmetric, so only one side can advertise, then in some countries that's fraud. In Mexico, for example, the incumbent president can't advertise for free. So maybe you call that a special case of strategic malefactors, where they're not really malefactors because it's just normal political behavior. So I think making all that strategic is part of the configuration of generalizing beyond the setting we talked about in the paper, my talk here, which is the strategic electors. And I think all of that is interesting, and I'm not ruling it out at all. It's just we haven't done it yet. Mm-hmm. And all of that's important to see how that how that impacts the statistical forensics methods, because all those things happen in the real world. And so in a sense, the real world won't care how exactly these distortions in people's turnout and vote choices are happening.
The reason it concerned me was it could be that when an election is close, one thing a party can choose to do is cheat, right? So now, of course, in some countries, it doesn't matter how much you're losing by; they just keep stuffing the ballot box until you win. But in a more democratic country, you can imagine the payoffs to cheating go up as the election gets closer, because it's harder to detect and you only need a smaller number of falsified votes, and that creates a possible correlation between turnout and the incentives to cheat, right? And so you can get, and actually it would be negatively correlated, which could be a problem.
Well, the funny thing about that is around the world, I put this slide up because Russia is up here and Armenia a little bit. I mean, in Russian elections, especially election type events in Russia, I won't call them elections in recent years, I suppose. There's no chance that Putin and United Russia are going to lose. They're going to get most of the votes anyway, but they really want more than 70% or more than 65%, or some countries, the dictator wants 99% of the votes. And so even though they're already winning by a big margin because, they arrested the opposition or something, they still want to cheat anyway. And so that may be where some of the points that are shown up here, even though that Russia case is here, other Russian cases are up here in terms of my overall distribution. It depends a lot on the particulars of the country. Susan Hyde and others have written papers and books analyzing, showing, and Susan had this great paper once called Why Invite Election Monitors and Cheat Right in Front of Them. So notorious frauds are something that a lot of people do. Not so much in the United States so far, though stay tuned. And here we think we have historically thought it's bad to cheat in an election and therefore you want to hide it. And some people have taken that to define election frauds as hidden. But you can have notorious frauds too. So I'm hesitant to say that we should generally say everywhere the kind of concerns you were addressing would happen, though certainly that happens in some places. And we can, again, put those into our agent-based systems by tuning the degree to which frauds happen, whether they're strategic or not, to be more or less small. So maybe have a negative incentive to create large frauds and an incentive to create small ones, and we'll see whether that makes a difference.
So one last question, which is about different kinds of fraud. So the fraud that it seems like your model is designed to detect and that you're sort of talking about here are either stuffing ballots or changing the mark on a ballot, so to speak. But in the U.S., at least, the most notorious election frauds I can think of actually don't involve those things. So, for example, Watergate, which did involve a form of trying to break the laws to win an election, had nothing to do with stealing ballots, right? It had to do with figuring out strategy of the other side and maybe getting some embarrassing information about them that you could publicize. Nowadays, I guess the preferred modus operandi is to get a bunch of internet trolls to post fake news online, which again has nothing to do with ballot stuffing, although you could think of it as a kind of fraud. And so I'm curious, first of all, the extent to which you would characterize those sorts of behaviors as fraud, and then whether you do or not, how is that going to influence what your model can detect as a fraudulent vote outcome?
Yeah. So the kind of frauds you talked about could be characterized as misinformation of a different type than I talked about in relation to this slide.
Yeah.
Not misinformation about the vote counts or the interim vote counts, but misinformation about the attributes of the parties to be voted for.
Right.
And we can easily, we haven't really thought of, we talked a lot about, but haven't implemented yet, this kind of misinformation, where you have the electors have their own utilities and they're comparing their utilities to their own positions, say, to the positions the parties have. These aren't spatial preferences for technical reasons. But you can imagine that instead of the positions the parties actually have, the misinformation gives to some or all of the electors false information, either increasing the variance and therefore the uncertainty about where they think the parties are, or shifting the mean view of where the parties are. And so I think that's another kind of misinformation that we have actively talked about, and I think I just forgot to put on my slide. Mm-hmm. So we wouldn't need to model the break-in to get at Watergate, or whatever Trumpgate is nowadays, or the Russian intervention. I wouldn't need to model the effect it has on Twitter, but I can say that some portion of the electorate is subject to this misinformation, and so in fact you don't have common knowledge about things across the electorate. You have different people getting different streams of information, which seems to be the era we're in right now anyway. And whether it's false in some cases or true, the fact that it's different will presumably make a material difference not only to election outcome, but to frauds. And whether you call that frauds or not, I'm not going to fight over the word frauds. I could easily see that's of interest to us and will be something we try to pursue.
All right. We have 5 minutes left, but no, looks like somebody asked a question and then canceled their question. So I guess we have no questions from the audience. I would like to, first of all, thank you, Walter, for being our presenter this week. I want to let everyone know that this presentation will be posted to our website shortly after the broadcast if you'd like to share it or watch it again later. I also want to advertise next week's talk, so join us Friday, February 14th. We will host Amanda Bittner from Memorial University of Newfoundland for a talk entitled Gender Conformity and Recognition, Self-Perceptions, Peer Perceptions, and Political Attitudes. You can check out our website, www.methods-colloquium.com, to get more information about this talk. Walter, thanks a lot for being here today.
Okay, thanks for creating this, Justin. It's really great.
My pleasure, and I hope to see everyone next week.